Good morning, E period. Sorry I can't be there with you today, but I wanted to walk you through some of the properties of exponents and working with exponential functions that we got started with yesterday. So everybody flip to page 2 in your packet and take a look at it's yellow in my image, but it's just a little chart that's in yours, in your packet, page 2. These are some properties of exponents. This is like the commutative property, the additive property that we've learned about in Algebra 1. But extended to exponents. And I want you to take a look at this and just sort of familiarize yourself with these properties because they're going to be useful and they're going to be common areas where people trip up in Algebra 2. So in the first one, it says if you've got two exponents that you're multiplying together and the base is the same, so a right here is the base. If you've got the same base, when you multiply them together, you can add the exponents. So the example we give over here is 4 cubed times 4 squared is just 4 raised to the 3 plus 2, so 4 to the 5th. You can't do this, you can't perform this operation if the bases are different. So 3 squared times 4 squared does not equal the 3, there's not even really a way to write it. 3 times 4 to the 3 plus 2, that doesn't work. So you have to have the same base. There's a similar rule below it sort of goes together. So multiplication and division go together, addition and subtraction go together. So when you're dividing, if you've got, I think let's say x cubed over x squared, when you divide, you can subtract the exponents provided the base is the same. So this is just x to the 3 minus 2, so x to the 1 or x. When you're raising something that already is raised to a power, so if you're taking something like x cubed and raising it to the 5th, you multiply the exponents together, or the powers together. So you get x to the 3 times 5, 3 times 5, and you get x to the 15. Similarly, if you have something like xy raised to the, let's say 3, the exponent is distributive if and only if you are multiplying the bases together. So if you're multiplying xy together, you can distribute the 3. I talked about this during the midterm review. So you can write this as x cubed y cubed. What you may not do, you cannot do this. You cannot say x plus, sorry, I'm going to erase that. You can't say that x plus y cubed equals x cubed plus y cubed. That is not going to work. You have to, just don't do this. You have to FOIL that out when you have situations like this. So this would be x plus y, sorry. This would be x plus y times x plus y times x plus y. You'd have to do all that FOILing work, which we don't want to do right now. Similarly, if you're dividing something like x over y to the 3rd, you can distribute the exponent into that and say that that's x cubed over y cubed. And these rules can run in both directions. So if I've given you something like x cubed over y cubed, you can write it as x over y cubed. We can go back and forth. So these rules are commutative in that sense. So what I want you to do is try simplifying just this first one. We're going to keep coming back to 1, 2, 3, and 4 here on page 2. So I actually only want to do the first one with you. You've got x squared times x to the 4th times y squared, and that whole thing is raised to the 5th. So that actually falls into the rule of this, when you have two bases multiplied together, and when you're already taking something raised to a power and raising it to a power. So let's distribute the 5 first. That would be our order of operations. So we're going to say that this is x to the 4th to the 5th times y squared to the 5th. And then you multiply your exponents in, and you say that that is x to the 20th, y to the 10th. That would be the final result.